The Trezor one is the original hardware wallet, launching all the way back in 2014. It's also been fully open source from the very beginning. So in this video, I'll just be running through how to make your own Trezor one using readily available off-the-shelf hardware. I'll be looking at a few different hardware configurations, basically one that reproduces the stock unit as well as one that improves it and adds things like a larger display, USB-C connectors, all while still being able to run on the stock firmware. While the Trezor one is certainly an older device now, it is still a great DIY option. It can be made extremely cheaply, and the process of building one will also help you better understand some of the hardware and security features that are running under the hood for pretty much all STM32 based hardware devices. So things like Trezor, KeepKey, Foundation Passport, cold cards, and so on. So let's get into it. And if you haven't already done so, hit subscribe, that way you can stay in the loop for content I make to help you find your way in the crazy and often hostile environment that is cryptocurrency. So I'm going to break this video up into 3 parts, which will actually cover different options on both the hardware and the software side at each step. And you'll actually be able to use all of these different steps interchangeably if you like. So firstly, on the hardware side, we'll be looking at the standard Trezor one development board that is on the MCU Dev GitHub page. That is one that has no soldering required and nothing much has changed there. And for that first example, on the software side, I'll be looking at how to use the modern Docker-based build approach to build non-production firmware. So this won't lock your hardware down at all and allow you to still use it for other projects if you like. So good for experimentation or development. So for the second part, on the hardware side, I'll be looking at some hardware options that give you a much nicer form factor, though there is a little bit of soldering involved. And on the software side, I'll be running through what you need to do to lock your DIY hardware down so it is safe to use, either through building the production firmware or through actually just flashing the official stock Trezor firmware onto your DIY device. And then finally, on the hardware side, I'll be looking at another no solder option, something that has a bit of a better form factor than the Waveshare development board. And on the software side, I'll just be running through what you need to do to modify and build the firmware to suit a device that uses different pins for the input and output functions, for things like the button and the screen, as well as showing you what you need to change if you want to have your own signed firmware releases that you use on this customized board. All right, so let's get cracking with the first example. So on the hardware front, this first one's mostly going to follow the Trezor one dev kit here that uses the Waveshare Core 405R board. Though one difference here is we're not actually going to worry about using the ST-Link adapter, so we don't need one of those. Rather than use the little display there, which is shown, I'm actually going to suggest you use this one here that's also on the Waveshare store, which is 2.4 inches. In terms of the buttons, I'm just going to use some of these. And the nice thing about these ones is we can also just cut 2 of the legs off we don't need. We can straighten the legs out that are there and just stick Dew-point connectors straight onto them. And we can also just put colored caps onto the buttons. We're not going to worry about the breadboard. The USB cable comes with it. And in terms of all the wires, the screen itself actually comes with some cables with a socket on one end and the Dew-point connectors on the other. And we'll just use 4 standard bits of wire to connect these buttons in. So let's put this together. So for the sake of consistency, I'll actually be using these colors for all of the wires in these examples that I show you. So basically all of the pins here are named. So what you'll have to do is work out which pin goes to here and work out where it corresponds on the underside of the board, which is where we'll connect everything. So I'll just wire that up now. Okay, so we've just connected all of our wires in, so let's flip the board over and look at the jumpers. So for this board, this is probably how it will come from the factory, and we just need to change a few things. Firstly, we want to change the power to come from the USB port, not an external 5-volt input. Basically, we can remove these 2 jumpers up here, but we do need to put this jumper here to connect pin PA9 to VBus. Otherwise, our computer won't detect the device when we plug it in. And to flash it using DFU mode, we're actually going to flick this switch here into the up position. So then we can actually connect it and flash it just using a USB port. So there we go. And basically what we can do now if we like is we can actually connect our buttons and our screen. So this is just our hardware assembled on the bench. Let's move on to the software. And this is the place where we are going to depart completely from the MCU Dev page, because the build process listed here is very out of date. So we won't be using that. We will instead be following the official documentation and the process on how to build the Trezor one firmware that uses Docker. So for this example, I'll just be using the Windows subsystem for Linux plus Docker desktop. The process for installing and setting that up is actually covered in my Building Crux from Source video over here, and it's exactly the same, so I won't go through it again. Now, the important thing to say is because Docker is going to be doing all of the heavy lifting, this process will be pretty much the same on any modern Linux platform, Mac OS or Windows through Windows subsystem for Linux. The other piece of software we are going to use is the STM32 Cube Programmer. And basically you can just download that from the ST Microelectronics website for whatever operating system you happen to be on, and just install it with the defaults, it'll work fine. Okay, so once we have Linux or whatever Linux environment we're using, Docker or Docker Desktop, and STM32 Cube Programmer installed, we are ready to go. Docker just runs in the background, so we'll just minimize that and we'll use STM32 Cube Programmer later. So basically then we just head over to the official Trezor wiki and we are going to follow a modified version of this process for building with Docker. So first thing we're going to do is just clone the GitHub repository for the Trezor firmware. So basically I'll just paste that command in there and just hit enter, and that'll just take a minute to download all the firmware. So once that's done, we'll just switch into the GitHub repository we just downloaded. And this is where we're going to do something different to what is in the documentation here. So the first thing we are going to do is run this command called export production equals 0. And the reason we're doing that is because the first thing I want to show you is how to build non-production firmware that won't immediately lock the bootloader and disable all of the debugging and programming ports on your board as soon as you upload it. And this is pretty much equivalent to the old export memory_protect command that you'll see in older guides like the MCU dev guide and so on. So anyway, so we will say enter. And look, while we could just use this command here and build for every model of Trezor, just to speed things up, we'll build only for the Trezor 1. So we'll say models 1, and we'll also skip core because we're not interested in the Trezor Safe 3, Trezor T or anything like that. And basically then we just need to put in the tag on GitHub that we want to build. So we'll go over to the Trezor 1 firmware page. So we'll go to the releases page, we'll go to tags, and we'll find the latest legacy release. In this case, that is legacy 1.12.1. So we'll just copy that and we'll paste that in there, and then we just hit enter. And there we go, the build is complete. And again, just one thing to double check is making sure that at this stage it was building with production equals 0. And if we go into Windows Explorer and go into the Linux section and into the folders for our WSL image, in this instance I'm using Ubuntu 24.04, go into the home folder, there's the user that I created when I set up the WSL instance, and there is the Trezor firmware folder. So basically now there is a new folder in there called build, and basically this is all of the firmware we just built. So for example, if we go into legacy, we can see that we have the firmware there and the bootloader there. So that is great. But before we can flash this onto our device, we actually need to combine the file from here and here. And basically where they are going to go is we go back up a folder level. If we go back up a few folder levels, we want to go into the folder called Legacy in the Trezor firmware repository, go into Bootloader, and there's a folder in there called Combine. And we need this script here called prepare.py. And basically we're going to put the files in this folder here along with prepare.py. We can just manually copy and paste them, and we'll just rename them to bl.bin and fw.bin because that's what the script is expecting. And now we'll go back here into our terminal. We'll go cd legacy, we'll go cd bootloader, cd combine. And if I just type in ls, you'll see we're in the folder with all of those files, and we'll just type in Python 3 prepare.py and hit enter. And basically it has now combined the bootloader and the firmware into one file. And if I just hit refresh in Windows Explorer, you'll see that is the file there, and this is what we're going to flash to our hardware. So let's do that. So now that that's built, we just come back over here to our board and we're ready to actually plug that in, and we should hear it get detected by Windows. And in STM32 Cube Programmer, we'll just select USB, and I'll just hit refresh there, and you'll see it's actually detected this board here. So now I'll just say connect. And over here on this tab here, this is where we erase and program the board. And look, if you've used this board for other things, this is a good spot just to do a full chip erase, just to completely wipe the flash on there, because occasionally you can have a situation where that will cause problems. Alright, so we've fully wiped that. So now what we'll do is we'll just navigate to that combined file we just made, and there is the combined file right there. So I'll just double click on that. If that start address is not already populated, we'll just set it to match this one here. We can leave all these other things as they are, and we can just say start programming. And basically now it's just going to upload it onto this board. There we go. So that is done, and if we've connected to the screen correctly, this should light up as soon as that has finished uploading basically, but it will say hard fault detected. That's normal, so we'll just unplug this. We'll switch this switch here to take it off DFU mode, so off programming mode, and just into normal operation mode. And over here, we'll actually open up Trezor Suite. So basically now, when I plug this device in, hang on. There we go. So when I plug that device in, it'll sit there, show us the firmware checksum, and then it starts up. And then once we get to this screen, it should get detected by Trezor Suite. So there we go. So we can say, yes, set up my Trezor, and we can test that our buttons work by using the recover wallet workflow. We'll just use standard. Essentially, this will ask us to cancel or confirm. So if I have these buttons wired up correctly, the red one should cancel that workflow. Yep. And if I just do it again, the green button should start it, which it does. So that's great. So basically that tells us that everything we have here is correct and works. And look, I'll just put this in a case so we don't short everything out when we're trying to use it. There we go, first DIY option. Certainly on the chunky side, you could definitely make it a little bit smaller if you tried, but you know, depending on how you use your Trezor, just sitting it on your desk, that might be just fine. And even with the specific board that I used in the hardware side of this first example isn't something you want, I would suggest that this is the starting point you should have for all of the DIY Trezors that you want to build, because it'll get you familiar with the software stack, how everything builds, and programming your board in such a way that if you mess it up, you can always erase the flash and try again. So with that out of the way, let's look at the second option. So that's some hardware that is a nicer form factor, it'll need some soldering, and some software that locks the device down. So while this first example was like comically large and not running production safe firmware, the next ones we're going to look at are two different options. Basically, for one that is quite small, really comparable to a retail Trezor 1, and one that also has a much larger screen, same size as this, but is in a much thinner package. And they'll both be running the same production firmware that is on a retail Trezor. So we'll start off with the little one. So basically the board we're going to be using to put in here is this little WeAct Studio STM32 core board. When you buy it, this is what you get. And it's actually a great little board in that it is very small. You can see, again, it's about similar footprint to a retail Trezor 1. It's nice and thin and doesn't have a bunch of extra peripherals that we don't need. It also has a nice USB-C connector on there. And the really nice thing about this one is it actually has a button that you can hold down to put it into DFU mode, rather than having to use set jumpers, bridge pins, or anything else like that. So this is the board that we'll use. And the final thing that I really love about this board in terms of DIY is that it actually has the pin numbers on both sides of the boards. I've actually got one here that I soldered up earlier. Basically what I've done is use the same color format scheme that we used in the first example in terms of the wires, and just put it into the corresponding pins exactly the same as in the first example. And I've actually just soldered two little push buttons in here, and they're sharing a common ground pin. So basically we'll just flash that with the firmware that we just built earlier, just to make sure that everything is working. So the one very important difference with this board is that I've also had to wire pin A9 to a 5-volt line, or a 3.31 would work just fine. On the development board one we had earlier, this was done using a pin header, but if you don't have this connection, connecting A9 to a voltage source, the firmware will load up, but your computer will not detect that the Trezor is connected. And actually, I'll just quickly mention, so this board here is the same one that is used in the low-cost Trezor 1 dev kit. Basically, it's this one here. The nice thing about it is it plays nicely with these big displays. Some of the other boards I have don't always reliably turn on when you power them on with these big displays. And the other thing that's really nice about this one, particularly when you're using it with a big display, is that the holes for the screen and the PCB actually line up closely. So one important thing to note is I've also hooked up the A9 pin over here on the board, because that was actually not mentioned in the low-cost Trezor guide. And I forgot to mention it for this one, but for this board here, to get into DFU mode, basically you need to bridge these two pins up here on the top corner where it says boot 1, and you need to connect boot 0 to a 3.3 volt line. And basically when you have it connected like this and you power it up, it will go into DFU mode. And then once you flash it, you can remove the wire from the boot 0 pin, and then move this header. You can basically connect boot 0 to ground. In this case, moving that header has done that. and then I can plug that in and you'll see it powers up. And the last thing I'll point out actually in terms of soldering these together is that both of these have been done using these sort of flexible wires. So basically this is just the sort of standard 30 AWG flexible cables that you get off Amazon or AliExpress or whatever. If you try and just use these sort of copper wires that are used for breadboard, you're going to actually probably have a bad time, because this wire actually, if you bend it backwards and forwards too many times, will just snap. Never mind the fact that this takes up a lot of space. So these little flexible wires are the way to go. So to program this with my test firmware that I built before, what I'm going to do is hold down the B0 button and just plug it in. And we'll put that over here. So just like before, we hit refresh and we can see it has detected our board, and we'll just say connect. And I actually still have this up from the previous board that I did. All the I/O on this one is the same as a retail Trezor. So I'll just erase the flash on here as well, just for good measure. There we go. And I will just program that with my combined firmware from before. And there we go. So we can actually see that has lit up, and it's actually going to say hard fault detected, just because we're still in DFU mode. So we'll just unplug that. We'll bring up Trezor Suite. And now we'll plug it back in. And there we go. That is loading up, so it should show up in Trezor Suite in a sec. There we go. And again, we can just test our buttons, same as last time. So one will be cancel and one will be continue. And there we go. So we now have our Trezor running on this little board here. So we've verified that everything is correct on the hardware and the software for this one here. So if we're happy that we've soldered this up and this board is never going to be anything other than a Trezor, we can move to flash the production firmware onto it. There are two ways that we can get the software to make it production safe. The first and the simplest mode is actually just to download the official Trezor bootloader from their GitHub. So we can head over to Trezor's GitHub page and go to this repository called data. And basically this is the data for various Trezor products. So we can actually click on bootloader. We can say we want a Trezor 1 bootloader, and we can just download the latest version of the bootloader for the Trezor 1, just as a file. And we can literally then just connect our little Trezor board, holding down boot 0 on this one. We will just refresh and connect to it. We'll full chip, we'll raise the flash. There we go. And I can literally just browse to the file I downloaded. There's the official bootloader, say open, and then just say start programming. And there we go, we can actually see now that flashed almost instantly because the bootloader is tiny, and we're now running the official Trezor bootloader. And basically what we can see here on the screen is just like a retail Trezor, it's actually telling us to go to trezor.io/start. Which will direct us to download Trezor Suite. So basically this board is now in the condition that a retail Trezor 1 comes in, where it's running a bootloader only but having no firmware. So if I open up Trezor Suite, basically it prompts me to do the device security check. I'm just going to say set up my Trezor, and the first step is the firmware installation. So because I'm running the official bootloader, I can just click install firmware, and Trezor Suite will install the firmware for me, just like a retail device. And there we go. We're on the official firmware, and we can just set this up just like any normal retail Trezor 1. And the important thing to say here is if you're really confident that the board you're using is compatible with the stock firmware, so uses all the same output pins and so on, you can just flash this firmware without having to build anything from source at all. So that's how I do it with the official bootloader binary from Trezor, and the great thing is that Trezor actually has reproducible builds, which means that it's easy to verify that the binary that Trezor are distributing, the one we just flashed, does match what was generated with the repository. That said, if you would prefer to build the bootloader from source, the process for that is pretty much the same as what we had in the first step, but with a few important changes. So you might recall back at the beginning we were setting production equals 0 to make sure we didn't lock down our bootloader. In this case, we want to actually go back and change export production equals 1. That will make sure that we have locked down our firmware. The second thing we want to do is make sure that our repository on our PC actually matches the repository that was used to build the production firmware. So what we're going to do is say git checkout, and if we go back to the Trezor GitHub page, previously we were building from this one here, but in this instance we actually want to build off the tag for the Bootloader release. So we'll just copy that one there, and we want to make sure that first we switch our repository to be that, and then finally if we go back to the command we had before, rather than build from this tag here, we want to make sure we're building from this tag here, which is the same one that we just checked on the website. The only change there is it just changes to BL 1.12.1, and then we'll hit enter. That's interesting. So our models 1 argument is not actually supported for that one, so we'll just get rid of that and run it again. Alright, so that build is complete and the bootloader.bin file has put itself in there. And if we just compare these two files, so the one we just built versus the official one that we downloaded, we can see that their SHA-256 sums are identical, which means that we have correctly built our production bootloader and can flash that onto our hardware. And the important thing I'll mention here is that the checksum of your bootloader file must match one of the official releases. Basically, the official firmware for the Trezor devices will checksum the bootloader part of the firmware itself when it starts up. If it doesn't recognize that the hash of the bootloader matches an official release, the firmware will refuse to start. So if you are planning to build your own production bootloader from scratch, just take the time to make sure that its checksum matches the official release that you are expecting. And unlike things like the Jade or the Sato chip card that I covered in previous videos, with the Trezors, if you are running the stock firmware, it will automatically enable all of the security features on the chip, lock it down, and disable any of the programming ports on that board. So basically now if I were to unplug this and hold down boot 0 and plug it back in, you'll see that it actually still boots into the normal mode of operating. So I'll just do that again just to be sure that I didn't mess it up. So that's just booting as per normal. So DFU mode is no longer available. No matter what I do in STM32 Cube Programmer, I can't connect to it. And this hasn't just disabled DFU mode. Even if I connect to it with an ST-Link V2 and try and get online with it, I can detect my ST-Link device, but I won't be able to connect. Simply put, this chip will not talk to any debugger or programming tool anymore. And it's important to say that while the protection on these chips is very good and generally prevents normal people from being able to access them, that is not the same level of security that you get in something like a Java card or a special secure element or something like that. This is still a general purpose MCU, and the things you've read about over the years where people have extracted keys from Trezor devices is precisely so essentially tricking the chip into turning these protection features off through glitching it when you are powering it up. And again, this isn't to say the protection isn't useful. It is still very useful, and you should definitely turn it on if you are planning to store funds on these DIY Trezors. So let's put these in the cases. So there you go. So these are our two devices from step 2. They're much better than this one, particularly when you look at the thickness of them. They're much better, and they're even with a small one in the same sort of ballpark as a retail device, so it is a little bit thicker. Still, they're both very nice, particularly this one with a nice 2.4-inch display. This is definitely my preferred way to use a Trezor One. So for this final example on the hardware side, we're going to be looking at another no solder option, though this one actually I think has a better form factor, simpler build, and lower cost than the one we looked at the very start. But on the software side, we're actually going to modify some things to make use of some of the buttons that are built in to the development board for this one. So this is the board that I'll be using here. Basically, it's called an STM32 Mini, and it's by the DevEBox folk. I couldn't actually find a schematic for this, but the key thing here is this is a version 31 of the board, in that there are earlier versions that have a different MCU on there that will not work for Trezor firmware. And basically you can see on this one here, we actually have 4 buttons, and we can basically make use of these last 2 very easily to be our 2 input buttons on the Trezor. Unlike our previous example, we don't want to go flashing production firmware straight onto this right now. So the first thing we'll do is rebuild the firmware using just the main GitHub repo and set production off. So we'll just say export production 0. We'll set GitHub back to the main repository, and we'll just leave it there for the moment. So basically for this board, we're going to modify the software so that it can use these two buttons here because they're really easy. And we're also going to change the connectors for the screen in that by default, it's going to be using them from both sides of this header pin row, so this row and this row. Whereas what I want to do is actually have something that can come out of a single row, which means we can just come out at 90 degrees very easily using one of these sort of 3D printed covers. They can just bend at 90 degrees and sit almost flush. And we can do the same on the other end and have a 2.4-inch screen that will sit down across the board like that. And because most of these 2.4-inch displays don't actually come with the pins soldered on, I'll actually just be pulling the Waveshare 2.4-inch screen out of this big one earlier and reusing it down here because it already has the pin header on there. There we go. So that is now hooked on there quite nicely. Essentially what we can do then is have a case that we're going to use where that is going to sit in there, and this screen can actually tuck its wires and stuff in just in there like that. And basically lid will go on top. And since we're using the built-in buttons, that is all of the hardware assembly we need to do for now. So let's look at the software side. Okay, so once we are here, we are just going to need to edit some files. Now, you can use whatever text editor you like. I'm just going to use PyCharm. Okay, so basically we are just going to navigate into Legacy because that's where all the Trezor 1 stuff is. And we're going to edit a couple of files. So we're going to need to edit setup.c. We're going to need to edit OLED.c. We're going to need to edit buttons.h. So basically buttons.h tells it which GPIO ports that we are using. So you'll see here that we are on GPIO port C using button GPIO 2 for yes and 5 for no. And that basically corresponds to this key that I was using earlier. Now, fortunately for us, for the yes pin, basically we just set that to be GPIO 1, and we set the no pin to be GPIO 13. And we don't actually need to hit save because PyCharm does that automatically. Now, if you just stop here and try and run it, it won't actually work. So we also need to go into setup.c and change the port configuration for what our GPIO buttons will be. So we need to change the numbers here as well to be 1 and 13. Otherwise, it won't detect our buttons properly and we'll just think they're held down all the time. So that is the change we make for our buttons. For the screen, it's pretty much the same. We just go into OLED.c, and for this particular board, we're going to leave the DC on port B, but we're going to change it from PB0 to be PB11. And we'll just change the comment there so that it's correct as well. For the sake of simplicity, we'll just leave the CS on port A, but we'll change it to port 3, not port 4. So basically once we've made those two little changes, all of the pins are in a nice, neat row. And just like before, we need to come over here and change the GPIO as well. So basically we had GPIO 4 on port A that we're going to change from 4 to 3. And then for port B, we're going to change GPIO 0 to GPIO 11. And there we go. So we've made the change in all of the files that we need. Now, what we have to do next is a little bit counterintuitive and is basically necessary because of the way that Docker does a build. So essentially, we are going to commit some changes to a local GitHub repository just on our computer, and then we're going to point the Docker build back to that. It sounds a bit messy, but it's actually quite straightforward, and it's really the best way to do it now that local builds are no longer officially supported by Trezor. So basically what we're going to do here is if we just type in, say, git commit, you'll see it will ask us for some information about who we are. So we can actually, and we can just put in placeholder information. Like we don't need to put in any sort of real information because we're not pushing this to a real GitHub repository. So we can just copy and paste the examples. And now if I type in git commit, it will show me the files that I just modified. So what I'm going to do now is say git add, and then just add those 3 files. Just copy and paste. And if you've got modifying other files and things, just leave them alone. We only are worried about these 3. And so what we're going to do now is we're going to say git commit, and we can type in any description at all because again, this is just for our PCs. And so here I will just type in remap IO for STM32 mini. You could write anything, then I'll hit Control X and I'll say save, yes, hit enter, and we can see now it's done that. All right, so that has basically just pushed the changes to the local repository that we have on here, and that's all we need to do. So now, just because I'm feeling paranoid and don't want to accidentally lock my board, I'll just export production 0 again. And what we're going to do is we're going to use a modified version of the command we ran before. So we're still going to say build docker .sh, we're going to skip core, so we don't need that. So rather than just build a release like we were before, we're actually going to use this hash here for the thing that we just committed to our local system. So I've just copied this from there and pasted it there. That's going to include the changes we just made. Now I put space, and now I need to point Docker back to this local folder with our repository in there. So essentially what I'll say is repository. Actually, I'll just cancel that. Actually, I'll just type in pwd, and that'll show the working folder just in case you've done this somewhere else on your system other than your home directory. So if I just bring this command back and hit space, I'm basically going to copy this and paste it there and just add .git and then a slash at the end and hit enter. And basically what it's going to do now is it is going to, so it's going to create a new environment, and you'll see it's actually cloning from here. You can see it's actually cloned the modified repository that we just made from our local PC into the Docker instance, and then it's going to build the code we want from there. Okay, and that is done. So basically now we can just do the same sort of process that we did before. Where is it? Python 3, oh, prepare.py, and there we go. So now, if I refresh that folder, we have our combined firmware that we have just built. So flashing that is the same as all the other ones we've done before. So we'll just bring STM32 Cube Programmer back up. I've got my board here, and I've shorted the boot 0 pin to 3.3 volts. That'll get this into DFU mode when we power it up. So let's just do that. So over here in STM32 Cube Program, we'll select USB. Yep, there we go, it's found it. Connect. Go into download, and we'll just full chip erase just for good measure. There we go. And I'll just hit browse and just make sure we're actually downloading the right thing, and that is not. So let's just go back to the Trezor firmware. We'll go into legacy, bootloader, combine, and that combine.bin is the one we want. It's got the most recent timestamp. I just built it, so let's put that one on and say start programming. There we go, download complete. Oh, there we go, and you can see that's lit up straight away, which tells us that we've not only connected this correctly, but the software changes we made worked. Hard fault detected, that's normal. So look, I'll just unplug this and I'll just take it out of DFU mode, and we'll get Trezor Suite back up. Okay, so that has worked. So I'll say yes, set up my Trezor, and we'll just check the buttons the right way around. I expect this button to be left and this one to be right, so I'll say cancel. Yep, that worked. And standard recovery. And then that confirms. Yep, so that does what we want. Great. So this is working on the hardware front, so we'll just put it in our little case here, just so I don't accidentally short it out on everything else on my desk. And there we go. Now, if you're paying very close attention, you would have just noticed that I didn't actually have to wire the A9 GPIO pin to a voltage rail to have this board be detected at all, which is unusual, because for all the others I had to do that or set a jumper. And the other thing that's a bit peculiar about this board is I noticed that even when I connected it to the computer with no firmware on there running, Windows actually attempted to identify it as a USB device and then failed to connect. Basically, the issue here is the data pins on this USB port are wired funny. So essentially what happens is if the device isn't ready to answer the computer straight away, the computer will just assume there's nothing there. So we actually need to plug in the port until it powers up, but the way these pins are wired, the data pins aren't actually connected yet. So once it's finished this startup here, if I plug that the rest of the way in, it will actually get detected by Trezor Suite, no problem at all. Whereas if I just unplug it and plug it straight in straight away, basically it will never get detected, and we'll see it in Device Manager in Windows as being incorrectly detected. So a bit of a weird quibble, and the only thing I'm not clear about is whether this is an issue with the specific board I have or whether this is an issue that all of these boards have. And so yeah, in terms of the size, you know, it is bigger than the previous one that I made, both in terms of its size. The length is about the same, and it is a little bit thicker though not hugely so. Definitely much smaller than this monstrosity. But you know, I think the size is certainly made up for by having a larger display. And if you are interested in doing this one on an extreme budget, you can also do it with a much smaller screen like this one here, and basically have it work like that. But again, personally, I'm not a huge fan of these tiny displays. If you can have a big device, you might as well have a big screen for an extra few bucks. And the last thing I'll mention is that this process that I've just showed you for being able to build a customized version of the repository is the same process you will need to follow if you want to build your own firmware that has all of the protections of the production firmware, but that is signed by your signing keys, not the official signing keys from Trezor. And basically, if you try to modify the hardware in any way, change the I/O or anything else like that, and still want the benefits of signed firmware, you will need to sign that yourself. And basically that process is quite involved. I'll actually put instructions for that on my GitHub, but essentially you'll have to go through, generate a hardware wallet that will sign Bitcoin messages to sign the firmware. You'll have to put the public keys for that into the bootloader. You'll have to basically build the bootloader, take the hash from the bootloader, put it into the firmware, and then build it all again. And then finally, you know, make sure once you've got it working with the Bootloader QA function, you'll need to then flash that onto your device and give it a go with production. So again, it's certainly a bit beyond the scope, I think, of what I can usefully share in this video, but I'll include all of that on my GitHub repo for Trezor DIY. So there you go. I really enjoyed the deep dive into doing this DIY stuff for the Trezor one, and I think it's fantastic, again, just to be able to build the device that pretty much started it all in terms of hardware wallets and has been committed to open source every step of the way. In terms of assembly and complexity, you know, it may seem a bit daunting, but really it's actually not that bad in terms of getting your head around it, putting it together, and having a great functioning and secure device that gives you all of the benefits of a stock retail Trezor. You know, fantastic option. I've got a lot more information about different screens, development boards, compatibility issues you might run into along the way, and so on, and more stuff that I could realistically cover in this video. Is already very long, so I'll be putting all of that stuff in a GitHub repository for Trezor DIY. So if you're looking for information about which hardware to buy, including hardware options that I didn't cover in this video, my suggestion would be that you just head over to that GitHub and check it out. Otherwise, if you have any questions, or if you've had experiences building your own Trezor, either from scratch or using development boards, you know, definitely let me know. I'd love to hear about it. Leave a reply in the comments. I do my best to answer everyone. Other than that, stay safe. Thanks for watching. I hope that was helpful. Hit like if you think that other people would find this video useful, and hit subscribe if you'd like to be kept in the loop about future content I make that helps people stay safe in the crypto space and to recover if they get into trouble. If you have any questions about this video or a topic that you'd like me to cover, just leave a reply.